My name is Marc Seefelder. I'm a founding partner at MING Labs. I'm responsible for design and innovation. With me today is Marsida.
Hello everyone, I'm Marsida, a data scientist at Alexander Thamm with a focus on NLP.
And online we have...
Miles, nice to meet you. I'm design lead at MING, based in Munich, focused on research-driven design projects there.
Great. So, good morning, good afternoon. I don't know where you dial in from. Maybe good evening. Today we want to talk about generative AI. We will record the whole session. Everything will be available on YouTube afterwards. And we will also have a Q&A in the end, so you please provide us with all your questions. Yeah, we're very excited. We want to focus quite a bit or shine some light at the intersection of design and AI. We believe it's still a bit an overlooked topic, but it's, you know, everyone is waking up to it, so not everything can happen in a chatbot. We need more different types of hybrid environments, and this is where generative UX or UX design plays a big role. All right. I do a bit of stage setting in the beginning, who we are, a little bit also about AT, where we sit in the tech stack. And then Marsida will present one project we worked on together for the past 6 months, NUI Care, the Pflegeleicht app, which is an exciting case. It's one of our flagship cases in Gen AI. And then we will talk about 10 lessons learned from Gen AI builders, because we worked on a couple of different projects. This year we had the big opportunity and are very fortunate to share now some of the learnings we had. It's a super exciting space, and it's changing by the day, as you all know. Yeah, and then we will have the Q&A, and we're really looking forward to some of your questions, because we know the presentation, but we don't know the questions that come up. All right, AT. So we are partnering for a couple of years already. AT those are the data and AI experts, well known in Germany, award-winning. MING, we're coming from UX design, strategy, venture building. And we worked on all kind of different projects in the past together, and we really believe, you know, in building the right team and bringing really diverse skill sets together, because only then we achieve early on in projects the, you know, to de-risk. And I think when it comes to Gen AI, it's very important to de-risk. I mean, you need to have data people, product people, design people, and domain experts all together, and trying to figure out what can we do in order to really leverage the power of generative AI. It doesn't work in isolation, either data or only design. It doesn't work anymore. Where we sit in the stack. So today we will cover mainly the application layer, so in between end users and the foundational models, whether it's large language models or diffusion models, and the end user, right? So we're trying, you know, it's all about how to integrate, how to fine-tune these models into user-facing products. And everything we will share after the NUI case study, especially the 10 lessons, they're all based on different projects we went through this year together with AT or between AT and MING. We also did a future casting, a speculative design project in Gen AI, where we tried to reinvent the booking experience for in tourism. We wrote a paper that is about to launch very soon. We gave a big talk at the Push UX conference about Gen AI and UX. And we just launched the Gen AI Gazette, genaigazette.com. You should have a look. Is a place where we collect all publicly available Gen AI enterprise stories. It's free. Everyone can use it. We categorize it by industry, by business function. And yeah, have a look. I will show a screen in the end. All right, that was stage setting. Now, Marsida, over to you.
Yes, thank you, Marc.
NUI Care.
So, yeah, NUI Care is an app and platform that provides support for the caregivers that take care of their relatives or family members that deal with health issues in their home environment. So in doing so, it has an app that is innovative, both in terms of UI, but also functionalities and features. And within this context, we created for NUI a chatbot, an AI-powered chatbot that we are going to present to you when it comes to its technical aspects in a bit. Like in the next slide. We move. So what the main approach that we use is the retrieval augmented generation approach, which is very popular in the field of large language models. What it does is that it uses custom data in order to provide more tailored answers to the users, not just using its pre-existing knowledge. So given a question by a user, like in this case, we first retrieve a text that has been provided, for example, from NUI that matches a question in order to provide this as a context to the generative API that will be able to provide in the end a factual answer. Therefore, especially in the healthcare setting, we don't want answers that are incorrect or contain information that is not true. So this is very important. But another aspect here that we implemented in the NUI case is also the personalization aspect. What we did is that we used the user profile data in order to enrich the user query and then retrieve the information from the specific database that is actually corresponding to this user type. Such user profile information can be, for example, the insurance provider for this user. Therefore, we get information that is actually answering the question as provided from these insurance companies, so to say. And this enriched query is also useful in the answer generation part, because the prompt is then enriched with instructions that correspond to this type of the user, like different brands, so to say, have their communication style, they require different answer length, and we can personalize it so that each answer is really tailored to that specific type of user and is not just general. So if we go to the next slide, here we can show you very briefly like the tech stack that we used. Of course, we have the data, like even though we are now working with large language models, data still remains important. It plays a key role. And by using Azure OpenAI, LangChain framework, and Qdrun as a vector database, all these synergies together resulted then in this conversational agent that you can sort of see on the right. And what was really interesting about it is that it has the memory feature, which means that it remembers a conversation, follow-up questions can be asked, which was not really directly possible before in the past through more conventional techniques, so to say. And at the same time, it allows context switching, which can be either user-controlled or automatic, and all the questions are answered through RAG that we introduced before, which means that they use really specific information that has been provided, in this case, by NUI. So now I will move to a next use case. This is just to get also have a look at this one, which is from the banking sector. It was called Language to SQL. So as the name suggests, it was about converting natural language questions to SQL queries. Here you can see a visual of the prototype that we built, where you can see that the user can enter a question in the natural language, and by clicking on submit, then the SQL query can appear. So you might wonder in which context will that be useful, and that we can see in the next slide. You can imagine, for example, within the banking sector, as we mentioned, a financial strategist that is working for the European Central Bank, and they would like to retrieve some kind of number related to a supervised bank entity, maybe getting a specific amount about this company and how it has done with reference to some attributes. An example question you can see there on the right, where the attribute, for example, CT1, is being asked with relation to Deutsche, which is like the bank entity, and then this query will then through different LLM components be analyzed in order to get the final SQL at the bottom, which allows people with no technical knowledge to get access to information which they otherwise would not be able to do without the help of a data analyst, for example. Here we can see what the exact sub-problems of this use case were. First, at the beginning, we have natural language understanding, which is actually the entity extraction, identifying what is being asked in the question, what kind of attributes, which bank entity is mentioned there. And after extracting those, the next step would be to normalize such entities, maybe expanding them to their full form or matching nicknames of banks to the full bank name, just to mention a few examples. And the next step would be then to, after having normalized or brought them to the right form, to match them against the data that we have in the database, or if they are attributes of the descriptions that we have in the database, in order to be able to use this information then in the SQL query as in terms of filters. And in the SQL query generation, the LLM is very useful because it can sort of analyze it in different ways. Even time constraints can be understood. But of course, in simpler queries, there is no reason why we should not resort also to some rule-based approaches. Therefore, a hybrid approach can be deployed in the last step. Here we can have a quick look at the data structure that we dealt with and the solution architecture. So given a query, somebody would like to know a specific amount of something, therefore always the aim was to get like a specific number. You can think of that number being stored in an Excel cell, and this number then being further defined by a row description, a column, a sheet, and a table description. Therefore, we have all this textual data that are then flattened out and stored in the database. But when we are given a query, we know then that we have to match all these text data in order to get to that specific Excel cell, if you will. So when approaching the solution, we distinguish between the bank identification, which is more of a clear-cut entity, and the attribute identification, such as table, sheet, row, and column, which can be a bit lengthier, a bit wordier, and therefore they need a different approach. In which case, we use like LLM entity extraction by using few-shot learning and examples, and to provide that these are then extracted correctly, they have to be then matched, maybe by doing some embedding search, like separately with those descriptions that we have in the database, in order then to get the corresponding code that we get to that information. And together with the output of the other component, this can then be leveraged in the final SQL generation module, which I also mentioned before. And with that, I hand over back to you, Marc.
Thanks, Marsida. I'll let everyone breathe a little bit, digest a little bit. Yeah, so we have, as mentioned already, Q&A in the end, so please note down all your questions. And now we will move into the second part, 10 lessons from Gen AI builders. We will split it up between me, Marsida, and Miles. And we will highlight some general learnings and then move towards the design aspects. And I think that's particularly interesting. We brought some visuals, so it's also a bit easier and more digestible, hopefully, than all these tables. Let's get started. So first lesson, this is how we dissect this whole space, everything that comes to us, whether it's a use case, a challenge, an idea. We always try to put it in one of those 4 buckets. So it's either a Gen AI retrofit, those are the assistants, the co-pilots, all these things that are strapped on top of something existing. Whether it's a service or a product, and to the right is Gen AI first, and this is more the space where you say, okay, if Gen AI as a technology sits at the core, it's just another layer in the tech stack, and whatever we come up with, whether it's a service or product, is truly natively generative, right? What could it be? And what would only Gen AI first and Gen AI at the core allow? So this is to the right, and then to the top is the outside view. So this is customer facing, a new customer experience, for example. And then to the bottom is inside view or organizational, or how could you use generative AI in manufacturing, for example. And that means for us, we see it in a way, retrofitting is just a phase. It's a bit similar to what we have experienced when, I don't know, when did the cloud come? 2006, 2007-ish, when it really becomes a thing in the enterprise, and you saw more and more software, moving to the cloud and was getting cloud enabled, and we still have things like Keynote, iCloud around as a presentation tool, which is okay. So you can sync something with the cloud, you can share it with your colleagues, but it's also very cumbersome, right? And on the other hand, you have something like Google Slides, and that is built for the web. It's built in the browser, or it's only in the browser. It's built for true collaboration. That would be a web-first presentation tool, versus Keynote is more a retrofit, right? So we think everything will move from the left to the right. So, by the way, not a political statement, to the right, and we will see more and more Gen AI first services and products, and it will just be another layer in the tech stack. Everyone will use it, and we also will not talk about it anymore. We also don't talk about the web anymore, right? So everything is web enabled, everything is built for the web. So will everything else built with Gen AI at the core, or Gen AI first idea in mind. Yeah, so that's the big one, right? This is the big breakthrough. Language is the new API. We all heard these lines. English is the new programming language. So is German, so is Chinese. I think that's really the big change and the big paradigm shift. Everything now meets on this layer of natural language, whether it's a machine, a workflow, a process, anything. And on this layer we can, as humans, obviously very well contribute. And that also means that we will be able, we are already able, but we will see this everywhere. We can talk to anything from your lamp to your washing machine, your car, coffee beans. It could be, you buy a plant and there's this QR tag on the pot, and then you have it, your new plant, your Strelitzia, you have it in your WhatsApp, let's say, and you can ask it, how much water do you want? How much sun do you need? You can take a picture of the leaf with the brown edges and say, look, you don't look healthy, what can I do? So the same you can do with your clothes, but also on the right, I think that's obvious that this has to happen. Weiland, I don't know, some of you probably know these heat controls. I have one in my apartment. If you don't have an instruction manual anymore, you're lost. You have 50 features and 4 buttons and a screen that is, horrible. And even to me as an interaction designer, it's it's impossible to use these things. But what Weiland could do, obviously, they could set up a content store, upload all instruction manuals of the past 50 years with the imagery, with everything else that is around happening on the web in forums, and really just provide all of that. And so I could just use this service, take a picture of my control, and then I could talk to it. And then I could figure out, okay, how can I reduce the temperature at night to 18 degrees, and it should warm up again in the morning, so I have wonderful 23 degrees when I wake up. That is a matter of 2 minutes then, versus right now, it takes 2 hours. Yeah, and then it's not just about text to text, obviously. It's not only about text to image also. I mean, we all see the power of Midjourney. We see now text to video, but in the end, it's input stream to output stream. And it can be anything. I mean, proteins are also just a string of letters. And what is very good with letters, it's a language model. And I brought one example here. It's Refusion, and it's actually built by 2 hobbyists. And they do something really cool. So they took a stable diffusion model and trained it on these spectrograms. And the spectrogram is just a visualization of music, right? Any piece of music you can visualize as a spectrogram. And then you have tools to turn, like I think it's torch music or something like that, or torch audio, to turn these spectrograms into music again. So they trained an image diffusion model on these spectrograms. And that means now you can say, okay, I want to create a track from Elton John about a certain topic, let's say Christmas. Here are some parts of the lyrics I would like to see. And then it generates the music based on a stable diffusion model and some other models around it. And that is just a showcase of, it's a combination of different things. And that is generative AI for us.
So, yeah, thank you, Marc. So another lesson learned is that hallucinations are a feature and not a bug, as many might think that have, for example, gotten some output from an LLM that can sound a bit misleading or incorrect. But we have to think that sometimes this exact output might be desired. For example, in the context of marketing, when we give the same instruction, but we get different outputs every time, this inconsistency is actually desired because it can invoke ideas in people, and then they can choose, for example, the best slogan. Of course, it's understandable that if we're talking about retrieving some information from a document, we want not any number or something misleading. We want it to be very factual, which is why we can sort of control this behavior of an LLM. There are different parameters. Such a parameter is also temperature, and the lower it is, for example, the more deterministic the answer can be. There are also other more advanced possibilities on how to control the behavior of large language models. We can see here from left to right soft prompting, bit-fit adaptation, and full fine-tuning. And these vary from low complexity and cost to very high as we move to the right. In soft prompting, we don't change anything in the model itself, for example, just the input embedding vector. And through that, we can get a bit more tailored results in bit-fit adaptation. Just to mention it quickly, only the bias terms, but not the weight parameters, for example, are adjusted. Whereas in full fine-tuning, this is a completely different game because we might have to retrain the whole model, which, as you might understand, will result in huge costs, and which is why it's implemented only when the added value will be definitely higher than what it will cost to actually retrain it. But just to mention them as possibilities. Many of you might have heard, though, of prompt engineering and prompt engineers. So what we can already say is that prompt engineers is actually a role that is very important, as they bridge a gap between business needs and the immense capabilities of LLMs. I mean, the knowledge is there, they have been pre-trained, but in order to get that knowledge, and this is the challenge that we are facing today, I think, is actually to know how to get it. And the prompt engineer is exactly important in that case, because they would know how to craft like a very good prompt to do that, although it might sound quite easy, it might be challenging in different scenarios. So prompt engineering then is exactly that very carefully crafted series of instructions that sometimes might have to be run a few iterations and refined until we are sure that we are getting the outputs that we want and it's not differing, especially in contexts where it's important that it's consistent. Prompt engineering is like the easiest way we have to deal with the LLMs in order to get them to work for our specific use case, so to say. And although it doesn't require technical knowledge, still it offers a huge amount of flexibility. Like we can ask an LLM to give us, for example, a text summary of a specific length, or change the tone of a specific text that we wanted to write to be more formal or informal, or even the format, which can be also a criteria or a requirement. Very often we want it as a JSON, maybe because we are using this component in a pipeline where we have to make sure that it is outputted in a specific format. And with that, I will hand over to Miles.
Great, thanks, Marsida. So yeah, we can now turn a little bit closer into this design topic. And one of the big questions is, what is Gen AI going to look like in terms of experience design in the next 1 to, in 3 years? And the question we really have is that, what will it look like? And we're kind of waiting for this moment. We're waiting for that moment for dominant patterns to arrive that will be ubiquitous across devices, across operating systems, such as pull to refresh. And we simply don't know what that's going to look like. And the only way we find that out is through experimentation and through building. Next slide. But what we can say is that chatbots are definitely the prelude, not the symphony. So in our opinion, the chatbot is very effective. It provides a very clear input-output. It makes kind of debugging or understanding the output of the model quite effective. And it's natural because it's using conversation. But there's a lot more that we can do. There's more that we can explore, and we'll talk about that. Next slide. Jacob Nielsen, kind of the father of UX, calls this, the first new UI paradigm in 60 years. So moving away from from this kind of task-based approach to really thinking about intent. So what does the user, what is their objective? What are they trying to achieve? What's their context? And now how do we get them there? And so this is where we're heading. Next slide. Previous slide. Yeah. And what we really see is that we have an opportunity to also reduce the burden on the user, the cognitive load of actually breaking down tasks, figuring out what programs they need to chain together, what processes they need to do, how can they fit all of this stuff into a row. And we actually can focus on their intent. So they can really focus on describing their objective, what is it they want to do, and then they can get an output, and then they can refine it as needed. And so, next slide. This means that new patterns are going to emerge around this intent-based approach. Here's an example of a speculative operating system from a few years ago, where you could imagine that maybe everything can fit in your inbox, whether it's calling a friend or working on a spreadsheet. Everything is a task in your life, and it's going through this kind of mental model of getting things done and being productive. So we don't know how this is going to work. But we do need people to experiment. Next slide. If we think about what that experimentation looks like, we can kind of go back to 2011, where we look at some of popular calculator apps, and they look a little bit wonky, they look a little bit funny in a certain way. But at this time, right, designers are trying to understand, how is this going to work? How are we going to, how much should calculators mimic the real world? Should we, use these elements like mimicking paper in example 3? How are we going to deal with multiple types of calculations, like you see in example 4? And so we kind of need this moment where things get a little bit weird, because that's where we're going to find out what works, what doesn't work, and so on. Next slide. And ultimately, the question is also around, how do we design for AI in the background, for AI processes actually happening? Once the command has been issued by the user, hey, this is the objective I want, how do we talk to them? We're not really used to that. And so we need ways within UI and within UX to kind of communicate with the user, to make them feel like co-creators, to make them feel involved, so that they can stay engaged with the process and feel they understand what's happening. Next slide. So one good example is Screenshot to Code, which you must have seen quite recently. And what you can see on the left side is a little sidebar, and it kind of does this funny scanning where it says, I'm scanning the page to generate this code for you. But it gives the user some sort of indication, right? So this is, I think, a good first example of how we can start to think about this, because as individuals, as users, right, we like to understand the process. We like to know what's going to come next. Why did it happen? And how could I change something to get a different output? And so this is, I think, a really good first example. Next slide.
Trying, yes.
So if we go a little bit like higher level, so not so much about UI and talk more about experience, we can start to think about what should user flows look like with Gen AI in the background. And of course, we normally work with linear journeys, personas, and these are really effective because they're predictable, they're simple, they guide the user, and they're also translatable. You can translate a linear journey, do X, do Y, very quickly into an algorithm, into code, and build that into your service. But what we also expect to happen is to see these dynamic journeys. So this means each step in the user journey is processed by our model, and the next step is predicted and provided to them. And that means that each user can have a different experience based on their context and their objective. And as designers, we're here to kind of set the parameters of what's possible. We're here to kind of create the walls to the world, and make sure the user can be free, but also safe, to say it like that. Next slide. I think a good example of this in the real world is something like paper maps versus GPS. So if we wanted to go to a train station, we might take our paper map and say, I'm going to go up this road, take a ride, down this road. We might even use road names to be specific so that we can actually, pathfind our way to the train station. But with a GPS, we say, I want to go to the train station. We don't know any roads. We don't necessarily know what direction we will go, but we're presented with options. Do we want to go by train, by bus, on foot, by car? And let's say we decide to go by bike. While we're going, if there's an accident, a delay, a road closure, the GPS is changing in real time and telling us where we're going to go next. Next slide. And so one of the things to think about is how do we move from flows to really designing user worlds. Again, another kind of example that we like is thinking about this transition in the video game industry from platformers, so these kind of side-scrolling games, over to open world games. So again, trying to promote more of a sense of user agency, of users being in control to shape their journey based on their own objectives and their context, while also creating rules, while also creating kind of a overarching linear journey to help users get what they're looking for from your service. Next slide. Previous slide, thank you. And so the challenge here for product people, designers, especially, is really to think about building for the audience of one. So now, how do we sit down with our bosses, our stakeholders, our teammates, and start to ideate about a product that can be unique to each individual that touches it? And I don't mean unique in terms of theming, of colors, or logos or something like this. I mean in terms of experience. I mean in terms of contextual information, right? In the NUI example, it could be something like, how complicated or how bureaucratic or how medically intense should our communication be to the user? Well, that could be based on their experience. Maybe they have medical training, maybe they don't. That means there's terminology they may understand or they may not understand. It's these type of nuances that we can start to get a hold of and start to make really unique experiences for each individual. Next slide. Another thing that I think is really interesting that we can think about is Tim Frick, who wrote in Designing for Sustainability, products and services that provide a streamlined yet enjoyable experience, putting the right things in front of users at precisely the moment or are more efficient and greener. And so there's a lot of concern around sustainability of AI systems, and I think that is earned and valid. But we also can see that we have an opportunity on the user experience side to use these dynamic journeys to make sure that we put only the right content, that we don't load the videos or the content that users don't need, that we don't load elements of the application that are not relevant to that user, but that we actually, provide to them only the core topics that they need. And of course, that can change over time as well. Next slide. And what that all amounts to is what we kind of think of as this digital ecosystem built for me. So this shift in control, or let's say a shift in focus of who is at the center of digital experience. And so before we shape ourselves to the user profiles that Instagram or LinkedIn say, right? They want your name, they want your email, they've broken you down into parameters, and you shape yourself and you pass all of the information in to fit. But what we think is coming next is really this ecosystem built for you. So you are this individual, and these systems now have to shape themselves to you, uniquely only to you. And so you become kind of the center of control with the web shaped around you. Next slide. So Let's recap. What did we talk about so far today? So we introduced the partnership between AT and MING Labs. Then we talked about 2 use cases. First one in this healthcare space with the NUI app, and the second one in banking. And then we went through these lessons, which are both around technical lessons, but also around experience design. And now we'd like to go ahead and answer some questions. But just before that, Mark, next slide. I want to just briefly introduce one new product from us, which is this Gen AI Gazette that Mark explained earlier. It is now full of over 100 cases that are categorized by industry, business function, and approach. And I think this is a really good tool if you're interested in bringing Gen AI into your team. Then this is a good way where you can kind of find some use cases, get inspired. You can use it to talk to stakeholders, give them real world examples of what's going on. So you may find this useful. And next slide. Yeah, thank you very much. And I think we'll begin the questions now.
Perfect. Thanks, Miles.
Cool. Then I'm going to read them out. So the first one is, do you have to pre-process the data for RAG? So the answer, we would say, depends always on the specific use case, but it is generally not recommended for RAG, especially if we have data that, if we use LLMs, and these are trained on data that is unfiltered from the internet. Therefore, this data hasn't been lemmatized or stemmed. It's in its full form, and we can use our text exactly in the same way in order to get better embeddings. However, having said that, we always have to clean our data. Like if we do web scraping and there are tags and the data is generally not clean and it can have some noise, it is always recommended to pre-process it in that regard for RAG. So the next one, have you had instances where you recommended to a client to not use generative AI in their product or service? Maybe you or Miles could answer that?
Yeah, I mean, usually it's the other way around, that we recommend to use it and they don't want to use it sometimes. I think there's a distinction between B2B and B2C. I think that's always important to understand. In B2C, precision is maybe not as important as in B2B. I mean, there are always cases where it is also important, like the NUI case. But very often, if it's about sports or anything like that, you could you could provide 4 answers, and then if one is right, I'm already satisfied. But if you're building heavy machinery and it's really about precision and exact values, and you cannot afford this. So therefore, that is, I guess, something you really need to look into. Is it if it's B2B, how can you make sure that you have in the answer just little room, and you can do quite a bit with RAG and with prompting, and then with building a second layer of challenging, where the agent or the AI is again challenging itself if it's correct, and you put enough guardrails in place so you can maybe achieve a level of correctness of 98%, 99%, and if that is okay or not. And then it's about, obviously, in the B2B context, what Marsida mentioned about how clean is the data, how much noise is in there, so that's this situation right now. In half a year, in 1 year from now, it might be very different already based on new breakthroughs on all sides, and that's one way to answer this question. I don't know, Miles, if you want to add something.
Yeah, maybe I will just add shortly that it's really important to focus on the use case. So it's not that one client might not be suitable to use Gen AI, but rather the use case, and then collaborating and doing really a deep dive with your the experts, the data scientists, the developers, the designers, and the product people, everyone has to collaborate together to understand if this use case is feasible. Because if you don't have content to put in the content store, then it's not feasible. If there's noise in the data, maybe it's not feasible. So each team might have reasons that a use case doesn't work. And so that's why you need to make sure you talk to each other. And when a team has a concern, these are the times we don't follow through on these use cases.
Okay, let's have a look at some more. The next question is, how can I prepare myself and my team for building with generative AI? Miles, is that maybe a question for you?
Yeah, sure, I can take it. I think one thing is to take a deep breath and not to get too stressed, because we're all really, it's all so new, and even people that are building with Gen AI also feel it's all so new. And then the second thing is to start to identify use cases, really start to look at processes. They can be internal or external, and understand, which ones are causing you the most pain, and then try to identify which ones would perform really well with large language models. And once you have some use cases, you can start to talk to stakeholders. You can see if there's going to be budget for exploring these, and you don't need to even necessarily build something to explore them, right? You just need to define the use case, understand from technical experts, people like Marsida, is it feasible? And then you can go have these budget conversations and start to identify if it's worth investing in building proof of concepts and so on.
Okay. Next question is it okay to have text chunks of different sizes, or is this not recommended? Right, I mean, when talking about RAG again, the text chunks that we split like the custom data into can play an important role into how the answer that we get is, if it's, for example, if we have hallucinations or not. Because if it's very big, first of all, it might also convey out of context information that is not really relevant if the question is very specific, and we have a text chunk that is like 3 paragraphs long, then in that case it can even convey like noise, and it won't add to the answer, but rather just distract away from it. So often there is not like a golden size for the text chunks. This is always up for experimentation. It depends also to the data, to the text that we have, and to the type of questions that are being asked. If they answer to those questions the way we would give them would require a more lengthy answer or information, or if the answer is just a specific number, in this case, we can work with smaller text chunks, because this is also more cost effective. Therefore, we have, I think, to play around a bit with the size, have a look at our data, see what kind of questions do we expect with regard to the text that we have. And this is something that we don't have to do manually. I mean, different vector databases or different frameworks such as LangChain offer the possibility to very swiftly play around with this, just increase the number, and it automatically will split the text in smaller chunks. Or if you increase it, we can also have the possibility there to decide if we want the text chunks to have overlapping between them, because experience shows that sometimes it can be better if there is some flow that is conveyed from one text chunk to the other. But even there is the possibility to decide the degree of overlap that we would like to have. And as I mentioned, LangChain is really good at this, has come to our aid when it comes to LLMs. It offers a very wide array of packages, and when it comes to chunking, it's worth like deploying and playing around in almost automatic way, so to say. So the final answer will be like, just try it out, and then the data will give you the answer by testing some outputs. Another question that I see here is a lengthy one. When retrofitting, are there segments of use cases in which Gen AI is still not mature to be implemented for clients? For example, my experience is that it's been good for speeding up ideation and content drafting, but not for autonomous decision making just yet. Well,
yeah, it's what I can recommend the Gen AI Gazette. There's a category called retrofit, and I think it's interesting to see what's happening. It's actually, I think of all the 100 cases, it's almost 50-50, retrofit and Gen AI first. But that is for me always a good starting point, depending on what industry you're interested in or what business function. So I go there because this is where we store all the case studies now, publicly available for everyone. And then, I take it from there. I don't know, Miles, if you have anything else on this. Okay, then what else? Do we have more questions?
So I have another one here. Suppose a piece of information can be found in multiple text chunks with slight shift in meaning between the different chunks. Which is the best way to choose the right text chunk? In short, how to deal with distributed and/or redundant information?
It's unfair, Marsida, right? You have to read the question and then answer it.
It sounds like it. So yeah, again about text chunks. So here, that's very true. It can happen in many scenarios where the answer to a question can be found in different pages, for example, in the document. And if a human would give the answer, we would combine both pieces of information so that the answer is considered complete. What we usually do with RAG is that we take just the top text chunk, and then this is it, what we provide as context with the LLM, because especially if it's a lengthy text chunk. But as I mentioned before, here is where the size of text chunks can help us, because if we decide that the text chunks can be of small size, then we don't have to use just the top one that is returned by the embedding search. We can use the top 3, for example, and this can be 3 lines long. And in that way, we get the best of information from different pages of our document. We don't even have to summarize it, because this is another technique that I would also suggest that is there available for us, that we can always summarize maybe 5 text chunks and then use the summarized text as a context, but there we run the risk that some information might get lost. But working with the text size, for example, can be the first way to go to try this out, to see that, okay, we have all the information, nothing is missing out. And if it's redundant, as you say, this is more of a text pre-processing thing, like making sure that information is not replicated, because you are sure that this can also skew a bit the results that we get in the end, making sure that our data is unique. Maybe we can, after we complete the text chunks, we can compare them between each other. Like that's, for example, an idea to see if they have a 100% match. Then maybe some information is really incorrectly just has been copy pasted inside, and this we can get rid of, just to mention a few ideas. Okay, so